One announcement, next week we have Linda McCarthy, School of Art and Design, who's going to be talking to us about alternative art spaces and a mystical cult, the Eleusinian mystagogues associated with the earth goddess and the goddess of the hunt in ancient Greece. So today I'm very pleased to be welcoming back to Alfred John Sims, who's a graduate of class of '84 and then a graduate school in '90. He's going to be speaking to us today about augmented reality. Welcome, John.
Thanks, Bill. Let me put this on. Okay. Can you hear me now? Yeah. There we go. All right. Okay. My name's John Simmons, and if you were listening to me talking to Sharon Yates here, you'll realize that I'm from Arkport, and I got my BS and my PhD here. Are there any other PhDs from Arkport out in the audience? Anyone? What's that? You gotta tell those guys. Go this way. Go long. Okay, better. All right, now everybody turn their heads. Okay, so as I said, or as Bill alluded to, I got here in the fall of 1979, and I got my PhD in 1990, where if you do the math, you'll realize I managed to take an 8-year program and cram it into 11 years. So I work for the Electric Power Research Institute, and we're still having feedback problems. I sound like I'm talking in a 55-gallon drum. You can just put it in a glass of water.
Keep talking.
Okay. I work for the Electric Power Research Institute, and most people call it EPRI. And the Electric Power Research Institute, our aims are to provide the public with safe, affordable, reliable, environmentally sustainable power. It's a 501c3 for the public good corporation, so all of our research has to benefit the public. And we do quite a bit of research. We have about 850 scientists and engineers working in several locations, and we do about $420 million worth of research each year. I think we're going backwards. I don't hear an echo. Okay. All right, we're in over 30 countries, and most of our work is done here in the States, though, but about 3/4 of it is done in the States and 25% to 30% overseas. So how did I get started in this? I started at EPRI 9 years ago last week, and when I first got there, they had Blackberries. And so I had a Blackberry. I had a Blackberry, and 9 months later, they took away the Blackberries and they gave us iPhones. And like any good geek, I went out and I started seeing what kind of stuff I could download. And one of the things I saw was an augmented reality app. And are you picking this up at all? Okay, an augmented reality app, and I had to see that, so I downloaded it, and what it was an app that allowed you to find restaurants. So if you wanted to find a Kentucky Fried Chicken, you would pick that from the list, and you would hold it up in the air, and you'd see a little Kentucky Fried Chicken symbol, and it would say Kentucky Fried Chicken, 12.5 miles in that direction, and then you could go, do this. Oh, there's one here, only 0.3 miles. And I thought it was great. So I was at a conference, and I was sitting in a bar where all real great ideas are hatched. And I was sitting next to a programmer friend of mine, a developer, and I said, you know, if you can find fast food restaurants with augmented reality, why can't you find utility assets? We could put the data from the geospatial information system, which is where they keep that kind of wear data, and workers could go out and use that and help them find stuff that they got to work on or whatever. He said, "Oh, I think we can." So we launched a project, and I'll mention that here in a minute. Now, I don't do this alone. I have some companions. Micah Tinklepaw. Does anybody remember Professor Tinklepaw? Yeah, so he introduced himself. I said, "Look, I got to ask, are you related to Jim Tinklepaw, grew up in Hornell?" And no relation. But anyway, so how many people have met two people named Tinklepaw in their entire life? So anyway, he's kind of a Silicon Valley kind of guy, and he's worked for a couple of organizations out there in the Valley, and I lured him away to EPRI with the promise of being able to do great things for humanity. And then in the lower left is Norm McCullough. He's actually a local boy. I work in the Knoxville, Tennessee office. His dad worked at Oak Ridge. And Norm has done various technological things. He reminds me of Doc Brown from Back to the Future. He's kind of crazy. He only sleeps 4 hours a night, and then he's working the rest of the time. So he's kind of my go-to guy when all else fails. All right, augmented reality. Simply put, everybody's got to have an what is augmented reality slide. Simply put, augmented reality is adding or enhancing your experience of reality by adding in data or other auditory, visual, textual clues to help you better do something. And the classic example is football. We've been watching football with augmented reality since 1998. You realize that? 1998. So I actually gave a talk in Austin, Texas on Tuesday. And one of the things I told them is everything you need to know about augmented reality you can learn by watching football. Okay? So they've overlaid information on the field in a way so that you know what's going on, but it doesn't interfere with your enjoyment of the game. If you remember, they used to put like a frame around it, and it would have the downs and the score and all of that, and you'd only be watching about this much of the game in actuality. So this is a huge, huge improvement. So we don't want to confuse that with virtual reality, which is an immersive technology where you actually step in to another version of reality, and that's what you experience. And there's it's a continuum. There isn't a dividing line between them, and people fight over these labels, and I'm like, why can't we all just get along and enjoy the technology? So, having made that distinction, I'm now going to conflate the two and tell you a little bit about Morton Heilig. He is what's known as the father of virtual reality, and he's also could be considered the father of augmented reality and to a great deal of it. He created a device called the Sensorama, and he patented it in like 1962 or something. But the Sensorama was really cool. Morton was a filmmaker, and he wanted to really bring the experience to the people. So he created this little booth, and you stuck your head in there, and say you were watching a movie where you were riding through Brooklyn on a motorcycle. You would be riding along, you would hear stereoscopically the sound of the motorcycle, you'd be watching things, but also when there was a pothole, you'd feel a little bump. When you went by a pizzeria, there'd be a little whiff of oregano. And so you were totally immersed in this experience. And this was back in 1962. There's the patent, the illustration from the patent. And buried down in that patent is there are increasing demands today for ways and means to teach and train individuals without actually subjecting the individuals to possible hazards of a particular situation. That, it turns out, is the key for what we call the industrial use of augmented and virtual reality. How can we make the worker safer, train them, make them more intelligent than they are when they're not instrumented, and how do we keep them safe? All right, a little bit of history here. I think the first instance of augmented reality and wearable technology, which we'll talk about in a minute, was in a book that came out at the turn of the last century called The Master Key by L. Frank Baum. Who knows what else L. Frank Baum wrote? Wizard of Oz. See? You get that at a liberal arts college. You talk to engineers, everybody's just sitting there. So anyway, Master Key, great book. In there, you put on spectacles, and you could see letters on people's foreheads. And like there'd be a letter if you were a letter M if you were a mean person, or a letter F if you were a fussy person, etc. So I don't really think anybody used that as a precursor for augmented reality, but it was cool that they were thinking along those lines back then. Where things really took off is in the 60s and early 70s with a fellow named Ivan Sutherland. And Ivan Sutherland created something called the Sword of Damocles, because it hung from the ceiling and it's going to fall someday and kill somebody. But you know, computers were massive, so they had to hang it from the ceiling. And all this thing did was put this parallelepiped out there, and you could turn it and spin it. And you know, the computer to do that took up a room. But anyway, he won a Turing Award. He's a big cheese in computing. Then a little later on, in 1991 or 92, this fella was working at Boeing, and his name is Thomas Caudell. And this is another funny story. Tom, who I work with, let me back up a little bit. I do work in augmented virtual reality and artificial intelligence. Tom is a big name in artificial intelligence, but he was transferred into this group for 6 months where they were trying to develop an augmented reality headset that would help Boeing workers run wires through the fuselage and more efficiently than they were doing. And in that little 6 months, he coined the term augmented reality. And now if you Google augmented reality, the first thing you see is the term augmented reality was coined in 1992 by Tom Caudell, and that's literally the only contribution he made to the field. But he's a great guy. And then Ron Azuma is up here, and what Ron did a lot of work in the foundational work in augmented reality, again in the late 90s, and he came up with Azuma's 3 rules of what augmented reality is. It's got to combine the virtual world and the real world. It's got to be interactive in real time, and it's got to be registered in 3 dimensions. So what does that mean? Well, if you have a map on your phone and you've got data on the map, that's not 3 dimensions. So it's not augmented reality. You pull up a map app and it shows you where you are. That's not augmented reality. It's got to be registered in 3 dimensions. So when I started this, when I started in 2010, I'm in LinkedIn and I'm driving around, and all of a sudden Ron Azuma comes up, and I'm like, I'll send him a friend request. So I send him a friend request. I get a message back saying I don't take friend requests. I'm like, oh, okay. Well, 6 months ago, I get a friend request from Ron Azuma. Yes. So I read about Ivan Sutherland in, I think it was Scientific American in like 1990 or 1972, and I was like, someday I'm going to do that. And it only took, 53 years or something to get there. Now, a little bit about wearables. We're all familiar with the concept of wearables because we've seen them in the movies and in cartoons for ages. The Dick Tracy wristwatch communicator. Well, we've got that now. And it does a lot more than just communicate. It's virtual diagnostic center for your health. And it tells you all kinds of information. It can remind you to take your medicine. It can tell you where you need to go and what you need to do. It's an incredible thing. Also in The Terminator, you'll see a little example of what we call social AR, where you look at a person, or you look at a situation, and the glasses or whatever the wearable tech is interprets that and tells you information back about it. And again, this was futuristic, but now we have that. I know a fellow that does social AR, and the purpose of the social AR is to meet people in bars. So he's got an AR app, he projects it on some wearable technology. You walk into a bar, you see somebody you're interested in, and it goes out and it looks on Facebook to see if they're single or if they're married or whatever, and it tells you about them, likes horses. So you have a come on line that you can then talk to them at the bar about. But what's amazing is that this is real, and if I could be a futurist for a second, I'm going to say everything that we saw as kids on sci-fi TV shows and sci-fi movies, that's all going to happen. I'm 100% sure of it. All right, so vendors. Geez, we got a lot of vendors of wearables. And the wearables, some of them are monocular. It's basically like a Google Glass where you're looking with one eye. Some of them are binocular, and they're what we call more immersive. And then there are makers of the smartwatches, devices that vibrate when they want to tell you something. It really runs the gamut. And I think eventually most of these are going to be replaced by something that we would call a phone today. Eventually all that's going to be packaged in there, and you're going to have 2 or 3 choices of who to buy from. And I tell people, these vendors, they come and they go, but mostly they go. Probably, this slide's a couple years old, so probably half of these people are out of business. But they had some really cool tech. Now, what caused this to happen? Why now? Why here? Why are we all of a sudden talking about augmented reality? Why are people familiar with it? And there are a couple of drivers here. First of all, we've got devices like this. Basically high-powered computers with sensors in there. This is just packed full of sensors that can tell information about your environment. And we have high-speed networks and such. We have the ability to manage stuff in the cloud, to very quickly download apps. One of the great things when I got my iPhone was I went home somewhere around the first time I got it, and I walked into my house and it picked up my Wi-Fi connection automatically. I didn't have to do anything. At the time, 8 years ago, that was a real big deal for me because I hated having to get on and log on to my home network, provide the passcode and all that stuff. And then when something got out of date, it would tell me, and I just hit a button, I could download the latest version. Again, my job prior to EPRI was working in an IT department at a utility, and updating everybody's devices was a nightmare. It was a total nightmare, and boom, now it's simple. So also, we have workflow enablers. The way we do work has changed fundamentally. It used to be that you would get a list of things to do all day, and you would pretty much follow the list. Now it's very dynamic. All the work management packages now are such that they're constantly optimizing what you're going to do next. And the old way of doing stuff just doesn't work. At the same time, we have all kinds of sensors and ways of talking to machinery that never existed before. So, if you got a ball mill, for example, and a bearing's about to go bad, nowadays that could tell you that. So exciting stuff in the world of industry. So there's three main ways, and I think this slide's out of date too, but there's 3 basic groups of augmented reality. First is kind of that work helper. It's having guidebooks, instructions, visual cues to tell you what to do next and how to keep you safe. There's the publish stuff. Getting information, non-technical information that may or may not be pertinent to you. There's some great applications out there One that off the top of my head is in Toronto, where you get to see, you can go to, what was it, Fort York, I believe, and basically relive the American attack on Fort York in the War of 1812. And you can stand there and get information, and that's overlaid on reality. And then this is just starting to come about, and this is a strictly augmented reality. Again, let's focus on the solution and not on the nomenclature. But there's a lot of collaborative stuff too. How do you get people to, in the same environment, looking at the same set of stuff and discussing it? And one of the solutions is AR and VR. So just to give you a few non-utility examples, this has actually happened, golly, probably 5 or 6 years ago. So this was really cutting edge stuff then. But the Oakland Medical Center, it's a 2 million square foot edifice, and it was built totally by the use of augmented reality by McCarthy Construction. And you can go see their webpage there. But the idea is there'd be a QR code on the jamb of every door. And what that would do is it would tell the augmented reality app where you are and which way you're facing. So now we're registered in three-dimensional space. Now you can take that tablet and look around and actually see all the stuff that's installed behind the walls. But it's better than that, because for every object in that building, from any place in that building, you can look at all of the documentation for an object or a device or some plumbing or whatever, and get their entire history from it. So in construction, this is a huge, huge deal, because they lose a lot of time going and looking stuff up. This one I love too. This is an example of retrofitting big ships. And what it does is, this is an engine replacement. You can take a model of this engine and plop it down, and so you're virtually reconfiguring it, moving it so it fits and all of that. And at the same time, it is changing the length and type of piping that is needed to plop it down and giving you the cost back. So you can actually move it around in real time and see this is $20,000 cheaper than putting it over here. All right, so let me go through some examples in the utility industry. These are basically cherry picking the projects that I've worked on. Remember when I said we decided in a bar that we were going to build something? This is our first project. Okay, so this is in 2011. And the way EPRI works is we work with groups of utilities usually. And we worked with Entergy, which is the utility in New Orleans, Natural Gas Fenosa, which is utility in Spain, Con Edison, which is New York, and New York Power Authority. So we worked with these 4 utilities, and we took their data and we overlaid it on reality. And if you stop and think about it, being able to find stuff is absolutely critical. If you think about Entergy, when there's a flood in New Orleans and you're trying to find equipment and it's underwater, it's a big problem. Or you're in Con Ed, you get hit by a snowstorm or Superstorm Sandy, and your service territory is flooded, big problem. Or your Long Island Power Authority, and you were hit with 2 hurricanes in 2 years, and you don't know where anything is anymore because they just kind of slap it all back together, and now you'd like to figure out what's supposed to be where. So the good news is that it worked really well. The bad news is that a lot of the companion technologies aren't there yet. Things like getting an accurate location and being able to store large amounts of data. So fast forward a few years. This is my second big project, and this has 11 utilities in it. And the goal of this, well, the goal of the first one is, can you use augmented reality in a utility? This project is, should you use augmented reality in a utility? So we are looking at the economic aspects. Does it save you time, money, less errors, etc.? And the ergonomics. What is the impact on the worker? What is the impact on their eyes, their neck muscles, their back muscles? Can they do typical day-to-day activities while wearing equipment? So the next set of slides are going to be walking through some of my examples. This one is Ameren. Ameren is a conglomerate of smaller utilities that were bought up, and they span much of Illinois and almost half of Missouri anyway. And they were rolling out some telecommunications equipment, so routers and fiber and stuff like that. And they wanted to use their linemen to do this. So, but the problem is the linemen are used to big, heavy things that need to be bolted down solidly and all of that. So they're putting these things on the pole and they're cranking down on the screws and they're busting the cases open and all kinds of stuff like that. And it's taken them a while to do it. So we helped them find a vendor. They created an augmented reality application to assist them, and the gains are pretty astounding. There's a 48% increase in efficiency when you're doing this. So basically they're doing it twice as fast as they did before, and the amount of broken equipment on the install has essentially gone to zero. Let me just back up. So you see here, here is where they put a wrench over top of where there's a screw there, or a bolt, and they tell them just how much torque to put on it. And so what you see here is you see this wrench, and this is reality. So they're looking at this device, I believe that's a router, and this is overlaid on top of it, so they see exactly where to go and what to do with it. This example is Southern Company. Southern Company is they're the ones that are really busy right now with Hurricane Michael. They are in the Panhandle of Florida, in Alabama, in Georgia, and this is an application that actually I think it's probably the best one so far we've done. But they have a substation, a large substation that has a lot of instrumentation in it, mostly developed by EPRI, and they wanted to know more about the equipment before they go in to the substation. A substation is an extraordinarily dangerous place. If you walk in the wrong place, you touch the wrong thing, you're dead. So this is supposed to help them with that. And the idea is that once they get themselves oriented, and there's some cool technology where they scan the ground at the gate of the substation, and then from then on the app knows where it is. So the app knows where it is, and no matter where they turn, they point it at the equipment, and they get information about the equipment. Just pops up. So there's a danger in substations that people will work on the wrong thing or switch the wrong set of switches. Okay, so can they still do it? Yeah, but it makes it really tough. You've got to be a special kind of person to make a mistake now. So there's that, and then let me, so you can see these are some icons that give a thumbnail about each piece of equipment. This is important up here. There are certain places in a substation where you shouldn't ought to go unless you're wearing a special kind of clothing. There's a situation called arc flash, where an arc is struck between you and an object. Very bad thing, especially if you're wearing anything like polyester or any kind of plastic, because that gets melted right into your skin. So there are areas of a substation where it's cotton all the way, and they have special suits for that and whatnot. So this tells you can see each one of these lines up with a piece of equipment, and then they can tap on it and get details on the equipment. Details like what is the maintenance history, what is the current condition, what's the temperature. The one thing you got to worry about in transformers is evolved gases. If there are sparks, it gives off acetylene and a bunch of other nasty gases. So this will tell you all the history about that. And you can see it's very, very portable. And it's, this has been a really big, big success. So here's a project that I'm doing in Korea. In fact, I'm going to Korea week after next to test this out. Korea has 100 million utility poles. And they want to know a little bit about all of them, or at least most of them are the important ones. So they're putting instruments on the top of the pole that tells you the temperature, the tilt of the pole, and the voltage at the pole. So what does that give you? Well, if you know the voltage at the pole, you know that everything downstream from that pole should be energized. So there's no outages and whatnot. If the pole reads 0, then you know a whole bunch of people have problems. The temperature is more for if something catches fire. You know, if the temperature reads 37 Celsius on a hot August day, that's fine. If it reads, 230 Celsius, you got a problem. And the tilt is kind of self-evident for various reasons, and you've all seen them. Utility poles start to tilt after a while. And some of them are out in the sticks, and you don't actually see them that often, but they're important nevertheless. So here's, this is actually a rendition, because I haven't actually been to Korea to take the real pictures yet. So an artist's rendition of the way it works, and it tells you, it calculates the current, it tells you the temperature, the pole tilt, and then if needed, you can open a work request so that somebody can come out and work on it, or if you got the credentials, you can do it yourself. So here's one with the New York Power Authority, and I'm really proud of this one because it has to do with worker health. Workers in utilities, they call them linemen for a reason because they're all men. I mean, virtually, probably 99.998% are men. And you get big burly guys out in the field, and there's a whole lot of testosterone going on. And none of these guys wants to be the first to go get a drink or to admit they have to go sit down for a few minutes and rest. So they will literally work until one of them falls over. And it's the job of the foreman to keep them from falling over. Well, we've got another program at EPRI that is looking into how to predict, heat incidents. What are the metrics going on? Turns out it's not straightforward. It's not your body temperature, just your body temperature. It's not just your heart rate. It's not just your O2 levels. It's not just the amount that you're sweating or not sweating. It's some complex system of those. But we're working with that group, and basically we said, hey, when you guys figure out what you want to measure, we'll be able to measure it. So we work with NYPA on this, and we hooked up these devices, something called a Hexoskin and a Zephyr, took those out of the health and fitness industry, people that want to monitor their statistics because they're trying to achieve a certain level. And this part is a wearable. It's exactly the same as this. And this is what a foreman would wear. And we didn't have any, we didn't know what to pick, so we just chose heart rate. Well, we measured 5 or 6 different things, but we didn't know how to test it, so we just picked heart rate. And this young man here is an intern, a summer intern. So we instrumented him up, and we had him do jumping jacks until we got the alert. But the idea is the foreman is wearing this helmet, and if somebody exceeds the magic combination of statistics, he's warned about it, and then he can look around and see where, Bob or Al or Ted or whoever, where they are, and they can go tell them to sit down before they drop dead. What's interesting is they outfitted, in the group that's doing the heat stress analysis, they outfitted, I think, 40 linemen with all kinds of instrumentation. And 2 of those guys, they started taking data and they said, hey, you guys need to go to the hospital right now. Because they were like this close to having a heart attack, just standing there. So here's one that I'm sure Duke Energy really wishes they had right now in production, or in what they needed a couple weeks ago. But Duke Energy is primarily in the Carolinas and in part of Florida. So they got nailed by the last hurricane pretty bad. One of the rate limiting steps to restoring electricity after a storm is actually going out and figuring what's broken. And having worked at a utility, I can vouch for this. If you have a hurricane or something, basically anybody with a pulse goes out and does damage assessment. It's typically done on paper or rudimentary electronics, prone to errors, prone to misinterpretation. The people doing it may not have the exact history or training to do it well, so it's very problematic and it slows down restoration. So when I came from a utility and went to EPRI, this was one of the things that said, I'm going to fix this because it's a huge problem. So the idea here is you have information in, I mentioned this earlier, a geospatial information system, a GIS. And utilities use GISs for a couple of different things. One, to figure out where everything is, and two, to store a network model. And so the idea is simple. There's a storm, there's stuff broken and missing. You go out, you project what's supposed to be there. So you're looking around and you see there's a pole, there's supposed to be a pole there with 2 cross arms, 6 conductors, and a transformer. There's nothing there. So all you have to do is circle it. And boom, it's entered in, it goes back to the system, and it's ready to be kitted at the warehouse and sent out on the next truck. The improvement here was tremendous. Basically, for one thing, typically you send out a 2-man crew or 2-person crew to do the storm damage assessment. One is doing the assessment, the other is writing it down. Cut that in half, which means you can have twice the number of assessors, and also dramatically improve the time it takes to do the assessment. So hopefully when this gets commercialized and fully deployed, it'll make a major impact. And this gives you an idea. This was from the trials. They wouldn't let us actually knock down poles, so we put sticky notes on them to say what was wrong with the pole. And this is what they're looking at. They're looking at a picture of the pole with the pole information, and if something's missing, they can just mention that it's missing. And they could do that without knowing anything about it. Anybody in this room could do storm damage assessment with this instrumentation. And the workers, they loved it. They loved it. So a little bit about our ergonomic studies. Again, the ergonomic study is looking at the biomechanical effects, eye strain, task performance, situational awareness, and safety. Again, we wire these folks up so they got all kinds of instruments on them. And we looked at 2 popular devices, wearable devices. One is this HMT1 that you got here. That's monocular. It's got, well, let me just show you. It's got a little flip down TV that you put in front of you. A lot of advantages. One, it works outside really well. 2, if it's in your way, it's bothering you, just flick it out of the way. 3, you can just flip this thing over and it's over on this side. So very handy. Cost about $1,500. And then the other device you may have heard about is the Microsoft HoloLens, which is binocular. It's more immersive. You can kind of walk through images in the field. Some of the disadvantage of that is you go outside and you virtually lose whatever you're projecting. Just like on your iPad, you take it outside, really hard to see. So this is some of the work they did. They had them basically followed them through their day, and they're doing various activities. And at the end of the day, they were taking measurements and whatnot. At the end of the day, they also got a survey where they filled out some Likert scores. And this is inside a power plant. We're going to do one out in the field on a transmission feeder, and then we're also going to do some vault work where they're down in the underground facilities. So a little bit about this. We have set EPRI's headquarters is in Palo Alto. We have labs in Knoxville, Charlotte, and Lenox, an office in Washington, D.C., and kind of an office in Denver. In addition to that, overseas, we have an office in Dublin, in Singapore, and Dubai. But we have set up facilities in all of these areas to show people augmented and virtual reality. We get a lot of important people walking through our office in Washington. So hopefully they'll catch on and we'll get a little incentive to use it more. So some of the things I'd like to do, we have a proposal in with NYSERDA, New York State Energy Research and Development Agency, with Consolidated Edison to basically locate their manholes. Obviously, if there's a lot of cars, a lot of snow, a lot of water, or whatever, it's difficult to find manholes. And is it your manhole or is it the telephone company's manhole? And so if there's a problem, say a fire in a vault, you need to know where to go to turn it off. And this tells you that, and it shows you where to go there. And then we're going to link it to some instrumentation. This is not an artist's rendition. This is an actual view, so that they will be able to see what's going on in the manhole before they pop the cover. And finally, this is some technology. EPRI for years has been doing research into doing sonic analysis of nuclear power plant steam pipes. These steam pipes, over time, they get little cracks in them, they get corrosion, they get various schmutz in there. And we developed this phased array sensor that can give you a 3D view of the inclusion in the pipe. And here's some representations of that, pictures I took at a meeting that we have, showing these are actual problems inside of a steam duct, this little cross section. But what we want to do is we want to be able to visualize it real time. So you pass over an inclusion and you see it right there on the pipe. And hopefully that'll save a bunch of time as well. So that concludes my talk. I'll take any questions if you have any. Yes, ma'am.
I'm curious to know, you provided so many interesting examples of why it works. I'm curious to know when people resist, like linemen who don't want to work with this technology, what are they saying?
Okay.
What are people like pushing back on?
Yep, yep. The question was, how is the acceptance of this technology? Is it age specific or whatever? It's a lot of times, I don't know, I don't have any stats on it, but it's very much age specific. The old burly guys, they're like, I don't need this stuff. And the interesting thing is, they've always said that. When we introduced laptops in the field, they resisted it. When they introduced radios back in the 60s, early 60s, they resisted. They just have consistently resisted. Part of it is because that they're assuming that somebody's going to be watching them to punish them because they made a mistake or something like that, or they're spending an awful lot of time at the donut store or whatever. But it's very much age dependent. And not always. Again, it's not. I don't have stats on this, but the younger guys seem to pick this up and are really interested in it. So yeah, yes, sir.
I found the examples you used very interesting, but I was surprised that there was no mention of the military. I would have thought that this kind of technology is...
The military, of course, has pioneered that. I didn't mention the military because we don't do business with the military, so I have no hands-on experience with military. But some of these device manufacturers have versions that they have produced for the military for various reasons. And the primary use case there is just situational awareness, knowing where everybody is, making sure you're not firing at your comrades. But yes, they've done a tremendous amount. Dr. Wang?
Can you make a transition between today and tomorrow?
Can I make the...
Well, to say something, what you were talking about tomorrow.
I really think that the question was, what's the future of all this? I think it's going to be ubiquitous. I think within 10 years, you're going to be using augmented reality the way you use your cell phone now. What the exact use cases are, I'm not sure. It could very well be very likely be on a phone. You know, right now they're making the phones, at least the Apple company is making the phones, so they can do artificial intelligence and augmented reality on the phone. You always could do augmented reality on the phone, just not as well as you can now. They're making them for this, in other words. But I also think that eventually, as far as the visual stuff goes, that most people will pop in a contact lens in the morning to not only make them so they can read their paper, there won't be any papers, so they can read their websites, and then they will have their various augmented reality applications 24/7. And yeah, I believe that. Yes?
I was thinking earlier about implantable kinds of things. You talked about a contact lens. So what about enhanced memory chips for your brain?
You know, it's not exactly my field. I know that I was reading just the other day on some tech website about augmenting people's memories using chipsets. But I think as much as there's real no dividing line between virtual and augmented reality, it's really a continuum. I think there's going to be a continuum between virtual and augmented reality and nearly every other technology, like artificial intelligence or enhanced brain functions and whatnot. I think it'll just become a big ecosystem. And people lump that under IoT or Industry 4.0 or whatever. But it's the availability of those sensors that I had on the slide, and the fact that you can talk to them real time and get information from them real time that makes it all possible. Bill?
Yeah. You mentioned the word sensor, what I'm interested in. Is there anything that you really want to do now that you can't do because of the lack of the sensing capability of the sensor?
From a utility perspective?
Yeah.
Okay, so the question is there something missing now, sensor-wise, that I would like to provide more reliable power? The number one thing on my own, John's list, is a $1 weather station. A weather station, you can go out and you can just staple it to the top of a pole and go to the next pole, staple it, next pole, staple it. Turns out, and I guess this isn't that surprising, the more sensors you have out there to measuring the weather, the more accurate weather predictions you can get. You can get micro predictions saying it's going to rain here, but not 100 yards over there. Why is that important? Well, if you're in the Midwest, you got an ice storm coming, you really want the trucks where the ice is going to be on the lines, pulling the lines down. You want to be able to concentrate your equipment where it's needed or where it's going to be needed. And really accurate weather predictions would be ever so helpful for utilities and the customers they serve. Yes? You're next, I see.
This is sort of question about utilities, really, maybe more than augmented reality. But why, given that there are all these storms now, why aren't we thinking of putting these lines underground?
Putting lines underground is okay. The question is, with all the storms, why aren't we putting lines down on the ground? Not my area of expertise, but from what I hear, it costs a tremendous amount of money to put them underground. Are they safer? Yes. When you have a problem with them, however, it's more expensive to dig them up than to just send a bucket truck out and to fix them. So most, modern communities, my development has everything underground. But older stuff, replacing all of the stuff that's out there would be horrifically expensive from what I understand. Yeah?
John, thanks for the informative talk. The story about being slow to adopt technology reminded me of when the Austrian army was trying to introduce telegraph, got a lot of resistance because the troops joked now we're going to have two enemies, the one
Front and the one behind.
as well as the one in the front.
Yeah. Well, the Army was slow in introducing repeating rifles because they were afraid the soldiers would waste bullets.
We've come to the end of our assigned time.
But I don't want to stop.
People are free to come up and look at the displays.
I do have a small example. Don't ask me to try this on. I have stopped demoing this because if anything can go wrong, well, the way it works is I put it on you and somebody says, I don't see anything, so I have to take it off you, put it on me, fix it, hand it back to you, and then you do something wrong and you can't get out of it, then I have to take it off, I have to put it back in. So I have stopped demoing this, but I will show you an application here, and let me just discuss it. One of the pieces of equipment that is used in utilities is called a voltage regulator, and it's basically a transformer that you can change the tap on one side so you can adjust the voltage drop or rise. There's several different makers. These represent the control panels. And prior to this technology that I'm going to show you, prior to that you would need to take a manual, and I've actually worked on this one, and the manual for this is about that thick. So you can imagine getting out of your truck, tromping 100 or 200 yards out into the field, and going to the voltage regulator, looking up and saying, I brought the wrong book, and then having to walk all the way back. So what this does is this is actually amazing because it goes over the installation, troubleshooting, repair, and deinstallation of a voltage regulator. And again, it used to take books and books and books, and it does it for all the major brands. And what's cool about it is one of the things you have to do with augmented reality is orient yourself is so that, you know, whatever the data is lines up with your context, okay? And what this application does, it uses actually the face panel, and it recognizes the face panel, and it lines it up based on the face panel. What that does is, and you'll see that if you come up here, I can move from here to here, and it'll just switch sets of instructions just like that, and go to the instructions for this, and it'll still be all lined up. So it's, I don't remember the stats on this, but the increase in efficiency was just unbelievable. And that's what's interesting about augmented reality is you do one project with this at a utility, one project, and typically you will save so much money that you can pay for the development of augmented reality apps for all your other use cases. And then it's just gravy. And you could say, why aren't utilities going full speed ahead? A lot of them are. A lot of them have drank the Kool-Aid, and they're like, we can provide much better service if we do our training and our work using augmented and virtual reality. It's just that there's a lot of stuff to transition over, and it's going to take a while. So if you want, come on up. Just don't step off, don't back up and step off the stage, and I'll show you this.